Welcome to online classes. This is Devalapalli Kiran Kumar, SA Physical Science, Gout High School, Matwada. Now we're going to learn about diffusion. What is diffusion, children? Do you know what is diffusion? See here, diffusion is the net movement of anything. For example, if you take atoms, ions, molecules or anything from a region of higher concentration to a region of lower concentration. Diffusion is driven by gradient in concentration. What is diffusion? Once again, diffusion is the net movement of anything from a region of higher concentration to a region of lower concentration. How diffusion takes place? By a gradient in concentration. Let us try the following activity yourself in the home to understand about diffusion. What you have to do? Try the following yourself in the home. Ask your friend or your sibling. Sibling means your brother or sister in your home to hold an incense stick and stand in a corner of the room. You have rooms in your home? So ask your sibling or friend to hold an unlit incense stick. Unlit means inka veliginchani. Then you go and stand in the other corner of the same room. Ask your friend to hold an unlit incense stick and stand in one corner of the room. Then you go to stand in the other corner. Now, can you smell any unlit incense sticks? Ammo, can you smell anything? No? Anything? Okay. Then, now ask you him or her to light the incense stick. Light means incense sticks means agarbatti veliginchamani cheppali. After some time, can you smell anything? Yes. Now lightened incense stick one corner to the another corner. Ammu, now can you smell anything? Yes? Okay. Stick odor. Okay, children. So what is the conclusion of this activity? You can conclude the following things. When your friend or sibling lights the incense stick, the scent in the vapor from form and smoke mixes with air and moves across the room and reaches our nose. Whenever the friend or sibling lights the incense stick, the scent in the vapor form and smoke mixes with surrounding air and moves across the room and reaches our nose. Then the movement of air, vapors of scent and smoke from one place to other is known as diffusion of gases. The movement of air and the vapors of scent and smoke from one place to other place is known as diffusion. Smoke and air, vapor of scent or gases are highly mobile. They can move easily from one place to another place. So other examples also are there for diffusion of gases. Let us see here. While you are spraying a perfume or deodorant, whenever you go to a whenever you're going to a function, you spray a perfume or deodorant to you. That is one example. And the other is whenever our mother or father in our home preparing dishes, while and after cooking we smell the dishes smell. It smells the, that is the example for diffusion. While cooking, the odors, the scent, the smells travel from the kitchen to our hall or our other rooms. We smells what is going on in the kitchen, which dishes are our mother preparing. We easily know. How we smells that? By the diffusion of that odor or scent or smells moves from kitchen to our nose. This is about diffusion of gases. Okay. Now let us see another. Observing the diffusion of liquids. You know liquids also diffuses. How the liquids diffuses we are going to see in the form of next activity. Can liquids diffuse? Let us see. That is activity 5. Take a 250 ml round bottom flask. You know round bottom flask? Yes. I will show you. With 2/3 of water in it. Put a few drops of potassium permanganate solution. You can use blue or red ink also instead of potassium permanganate solution. Using a dropper, you pour a few drops of potassium permanganate solution into that round bottom flask. What happens? Observe the flask. Now I am taking a round bottom flask and water in it up to 2/3 of the volume of the flask. Now I am adding potassium permanganate liquid drops and see what will going to happen. See how potassium permanganate liquid is diffusing in the water. See how beautiful is the activity. I am adding some more drops. See the liquid potassium permanganate drops are spreading across the water. In this way, liquids also diffuse in liquids. See how beautiful the activity is. Observe the diffusion of liquid in water. In this way, liquids diffuse in liquids. What happens after adding potassium permanganate to the water in the flask? Yes, how much time does it take the color of that potassium permanganate to spread evenly throughout the water? How much time it takes? You observe it. And what you conclude from this activity? See students, these are the diffusion of particles of solids into liquids. Next activity. Take a beaker full of water. Take a beaker full of water and add a few crystals of potassium permanganate to it and observe the changes. What are the changes occurring, you have to observe. You can repeat it with crystals of copper sulfate also. Copper sulfate is a blue colored crystals. You can do this activity with copper sulfate also, but here we are doing with potassium permanganate. After adding potassium permanganate crystals, do you observe diffusion? Let's see. Here I am taking 250 ml round bottom flask and water in it up to the 2/3 level of the round bottom flask. Now I am adding potassium permanganate crystals to the water. See what will happen and how diffusion takes place. See, the crystals of potassium permanganate, solid crystals, slowly diffusing in water. Observe the diffusion process carefully. How this diffusion is taking place. See how beautiful it is. The solid crystals diffusing in liquid water. The diffusion is, observe the diffusion, how it is, and compare it with the gases and liquids. How gases and liquids diffused in aerial activities and how these solid crystals diffusing in water. See, the diffusion is faster or slower than the observed in the earlier two activities. And conclusion of this activity, solid particles also diffuse into liquids like liquid in liquids. What is our conclusion? Solid particles of potassium permanganate crystals also diffuse into liquids just like liquids in liquids. So children, particles in liquids. Let us see what are the conclusions of these three activities. See here, from earlier three activities, we easily conclude that solids and liquids diffuse into liquids and gases diffuse into gases. Uses. What are the uses with the diffusion? Certain gases from atmosphere, particularly oxygen and carbon dioxide, diffuse and dissolve in water and support the survival of aquatic animals and plants. Aquatic animals means నీటిలో ఉండే జీవరాశులు. How they are surviving? Because of the diffusion of oxygen and carbon dioxide in water. Oxygen and carbon dioxide dissolve in water and diffuses in liquids. So the aquatic animals can easily breathe in and breathe out with the use of diffusion. And doing our respiration also. In our respiration, oxygen diffuses from lungs into blood. Oxygen is very important to us in the respiration. Here in the lungs, our oxygen diffuses into blood. And reversely, carbon dioxide diffuses from blood to lungs. In inhaling, we take inside oxygen, it diffuses from lungs to blood, and reversely carbon dioxide diffuses from blood to lungs and we exhale out that carbon dioxide. Therefore, diffusion is very important process for all living things. And solids, liquids and gases diffuses into liquids, and rate of diffusion of gases is higher than that of the liquids or solids. Now, diffusion of two gases with the help of one lab activity. Are the gases all diffuses same? Children? Are the all gases diffuses same? Let us see how two gases diffuses. We have to compare here diffusion of two gases. Which gas diffuses faster and which gas diffuses slower than that of. Let us see in the form of one lab activity. See here, what is the aim of our lab activity? To observe the speed of diffusion of two gases. Here we have to observe the speed of diffusion of two gases. For this we have material required. Here, long gas tube with scale, liquid ammonia, hydrochloric acid, pieces of cotton, two rubber cocks and pair of tongs. What are the materials? Once again, long gas tube with scale, liquid ammonia, hydrochloric acid, pieces of cotton, two rubber cocks and pair of tongs. Then procedure. How to do this activity? What is the procedure here? First, take a long narrow glass tube. Take two pieces of cotton, soak one in hydrochloric acid and another in ammonia solution. Take two pieces of cotton, soak one in hydrochloric acid and another in ammonia solution. Then insert them separately at the two ends of tube with the help of tongs. You have to take the help of tongs. Don't touch barely with your hands. Insert the two cotton pieces which are soaked in hydrochloric acid and ammonia separately at the two ends of the tube with the help of tongs. At the same time, you have to close the ends of the glass tube with rubber cocks. Close the two ends of the glass tube with the help of rubber cocks. Then observe what is going to happen.
To study the diffusion pattern of two different gases, let's perform a simple experiment. We require ammonia and hydrogen chloride solutions, two small cotton balls, 50 cm glass tube open at both ends, and two rubber corks. Take a cotton ball and dip it in ammonia solution NH3. Dip another cotton ball in hydrogen chloride solution HCl. Place the two cotton balls in the glass tube at the two ends simultaneously and close the two ends of the tube with rubber corks. Inside the glass tube, gases from the two solutions will begin to move in the opposite directions to each other. After some time, ammonia gas and hydrogen chloride gas will meet and react to form a white solid ammonium chloride. Mark the point where the gases meet and form ammonium chloride. Measure the distance dNH3 from the ammonia end and dHCl from the hydrogen chloride end. Ammonia gas will travel a longer distance, 30 centimeters, while hydrogen chloride will travel a shorter distance, 20 centimeters.
What are the observations and conclusion here? Two liquids gives off their own gases. Hydrogen chloride, hydrochloric acid gives the white ring. And note down what is the distance from the hydrochloric acid side. Note it down. Then how much the distance from the ammonium side. Note it down. From the measurements, we can say that the ring is formed near the hydrochloric acid gas side and far from the ammonium side. The ring is formed near to the hydrochloric acid side and far from the ammonium side. With these distances, we can easily conclude that ring is near to the hydrochloric acid gas side, which means hydrochloric acid gas is traveled slower and ammonium gas is traveled faster. Yes, isn't it? Due to the speed in the given same time, hydrochloric acid gas travels slower than the ammonium gas. Due to that, ammonia travels long distance, which means more distance when compared to the hydrochloric acid gas. That's why the ring is formed far from the ammonium gas side and near to the hydrochloric acid side. This concludes that ammonia is traveled faster than hydrochloric acid gas in the given observed time. With this, we can easily conclude that the given two gases, ammonia is traveled faster than the hydrochloric acid gas. This is the conclusion of our activity. Let us take some homework. 1. Explain the diffusion phenomena based on the states of matter. Number 2. How can we smell perfume sitting several meters away from the source? Number 3. Write material required and procedure of the experiment, the speed of diffusion of two gases.